Last time, we looked at the motion of a battery-powered car moving at constant speed in a straight line, and we took detailed data of its motion over particular distances and particular times, and we turned that motion, those numbers, into a graph, actually into a couple of graphs, a distance versus time graph and a velocity versus time graph. What you need to keep in mind is that these graphs are abstract representations of actual concrete physical events. So you saw the car moving through the distance and you saw the time on the stopwatch increasing, and then we turned that into a picture. And what you should have gotten was a diagonal line going up and to the right. And I have that on the board behind me. I want to talk about what do the other options for distance versus time graph mean when we're looking at constant speed motion. We could have a diagonally down to the right graph. We could have a horizontal line graph. What we cannot have is a vertical line graph, because that would require being in multiple places at the same instant. Because what you need to remember, the horizontal graph, the horizontal axis is time, and time is counting upwards, and the vertical graph is your position. So if you have a vertical line, like I have on the right-hand board behind me, that means that you are in multiple positions at the same instant of that reading on your stopwatch. I can't do that, and I don't know anybody else who can do it, not even my wife, and she's really good at being in multiple places doing multiple things, but she can't do them at the same instant. So you should never see a vertical line graph when we're talking about distance versus time. But let's take a look at several instances where we have those other three graphs, and I'll be doing an activity that I call walk the line. Normally, you would be doing this. I'll be asking for volunteers and have you get up out of your seats and have you walk a line that is going to be projected for you. But you're not here with me, so I'll be doing it, and you can watch my version of doing this. We have a sonar device here. This emits sound pulses that are so high-pitched that they sound like clicks to our ears. And they will then bounce off of whatever they hit. And it's connected to the computer here that will be making a graph of the motion, and I will be walking in front of this forward and backward along those lines that I had taped out for our last activity. And it's going to measure my distance from there, and I have it set up directly over the 0 line. So I'm going to be looking at the distances back every half meter and trying to match up my motion with a graph that I'm going to put on the screen here. All right. On the left side here, I have the view over the left shoulder of the Sonic Ranger going back into the room, and you can see the little blue stripes from where I put down half-a-meter markings. And the Sonic Ranger is directly over the 0. And then on the right side, I have a graph that I'm going to try to walk in front of the Sonic Ranger on the lines, and I'm going to use my shield here to try to provide a flat surface for the sound waves to bounce off of and come back to the sensor. And what this says is I should start at about 3.5 meters back from the Sonic Ranger, and I should start out by having my position not change. And then I should walk pretty steadily towards the Ranger. The distance between me and the Ranger should steadily decrease for the remaining time after about 1.5 seconds. So I'll get set up and we'll see how I do with this. One, 2, 3.5. All right, there's 3.5. And selected that guy. Let's see how this goes. All right. Take a look at this. I had to take a second to get into position, but then I stood there, and then I was a little late in moving forward, and you can see these two lines diverge. So the slope of the green line was a little bit steeper than the slope of my line. That means that I was moving a little bit too slowly. Let's see if clear latest run. All right, so I can clear just the run, and we'll see if I can do that again, and then I'll switch to a different graph, and we'll see how that goes. So I need to get back to this guy. All right, I did a little bit of a better job there, but I slowed down at around the 3-second mark and then had to speed up to continue moving with the line. Let's see here, let's clear latest run. All right, let's use this run. Now this time, this says that I should start out just inside 1 meter away and stand there for a little over 1.5 seconds. And then the distance between me and the sensor should increase back to about 3.5 meters fairly quickly, and then it should decrease again. I need to reverse direction and move back towards the sensor slowly. All right, so let's get in position here. And then I'm going to stand still until the 1.5 second mark. All right, so I was a little bit too far away, and then I moved farther away here too slowly, but I did get the line to match up at the end there for my motion. On the whole, I have to say this works better with multiple people doing this. Let's see here. This one's going to be tough. So it says that I should start a little bit at about 1.5 meters. So let's see here. That's 1, that's 2, so a little bit behind there. And I should start out by moving backwards to about 2.5 meters. Stop. That's the horizontal line. And then I need to move forwards towards the sensor more quickly than I moved away from it. All right, so let's see about synchronizing this. A little bit behind. Yes, there we go. All right, that's the best one, and I should probably stop here. So I start out by moving away from the sensor. Notice that this line means that I'm increasing the distance between my chosen 0 point, which is the sensor. The sensor is sitting at 0. I'm starting a little over 1.5 meters away, and I'm immediately increasing the distance between the sensor and me. And then once I get to this particular time, I'm going to stop and stand still for that amount of time. And then when I get there, and I was a little bit late in getting moving again, but I need to start moving back towards the sensor so that the distance between the sensor and me decreases. All right, so what we have is a positive slope, means that the distance from the 0 point and the item of interest, in this case, me, is increasing. Horizontal line means that the speed is 0. That means that the object is stationary. And then a negative slope means that the distance between the object of interest and the chosen 0 point is decreasing. All right, let's review what I just did a little bit and look at those 3 distinct line segments of forward motion, backward motion, and no motion, and consider how those lines relate to my velocity. All right, the first line segment from the first graph was a horizontal line, kind of like that. And what that meant was I was not moving. I found my starting position on the floor, and I just stood there for the appointed amount of time. All right, so that feature right there is the y-intercept. In math class, you would call this the y-intercept. This is the starting position. And the fact that it's a horizontal line means that the slope is 0. Slope equals 0. And what that meant physically was I was not moving, which translates in physics to velocity equals 0. So if the slope is 0, remember slope is change in y divided by change in x. So slope is change in y divided by change in, well, in this case, it's not going to be y and x, it's going to be s and t. So change in s, change in t. That's slope. In math class, it's y and x. Here right now with this graph, it's s and t. And remember, velocity is going to be a change in position divided by a change in time. And when you have no change in position, the top number is 0, and the top number of your fraction being 0 means the whole value of the fraction is 0. So our velocity is 0. Another line segment that we looked at was a line segment of positive slope. So slope is positive. That's a t. Notice that my t's have tails, and that's a plus. So the slope is positive. And what that means is that the distance between our object of interest and our chosen 0 point is increasing. So distance between object and chosen 0. What you need to keep in mind is that anytime you have a 0 somewhere, it's most likely a chosen thing. So you've chosen the position to be a particular place, to be 0, to be measured from. So object and chosen 0, distance between the object and the chosen 0 is increasing. If the slope is positive and the distance between them is increasing, that means the velocity is going to be positive also. Because whatever is going on with the slope, that's what's going on with the velocity. And then the third segment that we looked at was, what if we have a diagonal line that is going down to the right? And again, we come back to change in position over change in time. The position is getting closer to the 0. So that means that the distance between them is decreasing, and this is going to be a negative number. Yes, it's allowed to be negative. So that means the slope is going to be negative. So slope is negative. Basically what we're going to do is we're going to take each of these three statements and do the opposite version of it. So instead of plus, now we have minus. Instead of increasing, we're going to have decreasing. And you saw that on the screen when I was walking towards the sensor. So distance between object and 0. And again, I'm saying chosen 0 because you saw me wheel the cart onto the floor and leave the sensor at a particular place. So the distance between the object and the chosen place where we've decided that's where we're going to put our starting of our tape measure, 0, is decreasing. And that means that the velocity is negative. Velocity is negative. And a negative for velocity just means I'm now moving in the opposite direction. This one, I was moving away from the sensor. This one, I'm moving towards the sensor. The plus and the minus don't tell you how fast you're going. All they tell you is the direction. And that's going to be a major theme in this section where plus and minus tell you about the direction of motion. Plus is moving away from the 0. Minus is moving towards the 0. Next, we'll have you look at some graphs on your own and consider what do these things mean.